Hi folks, I'm Ali physics teacher. In this video I will talk about logic gate, and this topic is from CIE IGCSE Physics. In this video I will explain different types of logic gates. I will also discuss about LDR and more about logic gates. So you can see here, I have one question for you, and with the help of this question, I will explain to you logic gates. So in this question, we need to understand what this question is asking us. The question is simply asking us state the name of the component. We need to state the name of the component, and the symbol is given to us here, as you can see. Now, how we can identify this symbol? In order to identify this symbol, we can break down this symbol into two parts. The first part is this symbol, and this is well known and very common symbol in DC circuits, and this symbol is used for fixed resistor. So this symbol is used for fixed resistor. Now, if we compare these two symbols, we can see the difference. Difference is here, these two arrows. So what these two arrows are telling us? These arrows are telling us light is shining on the resistor. If the light is shining on the resistor, we can also simply say that its resistance is depending on light, and we can call this type of resistor light dependent resistor, or which often we call LDR. And this part has only one mark. We simply need to write the name of this component. So here is our final answer. We simply need to write down LDR, or light dependent resistor. Let's move on to part B now. Here is part B. Part B is simply asking us, in the space below, we need to write down the table for NOR gate. So NOR gate. So the first thing we need to understand, NOR gate is a combination of two gates, NOT plus OR gate. So these two gates together, we call this NOR gate. Now, first of all, let's try to look at different symbols of logic gates now. So this symbol is used for NOR gate, N-O-R. So NOR gate. So this symbol is very important for us to understand. So now you can see here, as it has two inputs. So this is input 1. I will say this is input 1, and this is input 2. And here is output. So this is output. Now we need to draw the table for this one. So let's try to draw table. So as you can see here, I already draw this table for you. So in this table, we can simply see that if the input, as you can see here, if the input is 0, means one input is 0. Let's say when this input is 0 and this input is also 0, the output will be 1. The second option we can see here, when input 1 is 0 and input 2 is 1, our output will be 0. So it simply means that if I replace this, you can simply see here, if I here now, if this is the input is 0 and one input is 1, output again will be 0. Now let's move on to next one now. So you can see here, if in one input is 1 and other input is 0, so simply we can say if one input is 1 and other input is 0, our output has to be 0 again. Now the last one, if one input is 1 and second input is 1, output has to be 0. So here I can write down if one input is 1, other input is also 1, output has to be 0. It is just inverter of OR gate. So if we simply understand OR gate, so the NOR gate is just inverter, means all the outputs will be opposite. If in OR gate, let me explain to you here. In OR gate, what we have seen, we can do comparison here for OR gate. So here, let's say input 1. Here I'm explaining OR gate only. If you are not clear, you can understand from here better. Input 1, and let's say here is input 2, and here is output. If one input is 1, other input is 0. So let me just write down again this one to give you better comparison. Comparison is very important. Let's say if input is 0 here, input is 0 here, output has to be 0. Next one, we can see if one input is 0, another input is 1, output has to be 1. So you can see here, I'm just following this one. Next one, you can see if one input is 1, other input is 0, the output for OR gate, it has to be 1. And the last one, we can also write down here, if one input is 1, other input is also 1, output has to be 1. Now we can do a quick comparison where you see here is 1 in OR gate, you see in NOR gate that is 0, meaning it's just opposite. Where we see 0 in OR gate output, we see 1 here. So this is very basic concepts. If you have this understanding, that's wonderful. So let's move on to next one. So here is our next question. This is part C. So let's try to answer this question now, how we can answer this. So this is part C, and this figure is given to us 9.2. We can see there are different types of gates. So first thing what we need to do is we need to understand these different types of logic gates. And then we need to complete this table. We have to complete this table, and the marks for these questions are also given here. Now, how we can answer this question now? So first of all, we need to identify these different logic gates. So let me show you these symbols. This is NAND gate. So if we look at this gate, we can simply say that this gate is NAND gate. N means NOT gate and AND gate. And this gate, let's see what kind of gate is this. This is OR gate. So you can see these two look similar. So I can say this gate is OR gate. So we can simply write down here, this gate is OR gate. So this is OR gate. Let me show you other types of logic gates as well at IGCSE level. You can see this is AND gate and this is NOR gate. We have already discussed, and this gate is NOT gate. Now, how we can answer this question now? So here, first of all, you can see here when input A for NAND gate, that is equal to 0, as you can see here, when this is 0, and input B that is equal to 1 is equal to 1. So we need to understand what is output here. So this is NAND gate opposite to AND gate. So it means this has to be equal to 1. Now, C is given to us. C is also 1. This input is 1 and this is OR gate. So we will simply say that output has to be 1 because this gate is OR gate. If any input is 1, output will be 1. Now, next one, when A is equal to 1 and B is equal to 0, so means when A is 1, B is 0, NAND gate again, it has to be 1. And you can see the C is given to us and C is 1. So simply we say it has to be 1. So this is 1. As you can see here, we got 1 and 1. So this is here. Now, the next thing we need to understand, when this is 1, means when this is 1, B is also 1. So what will be the output? What is D here? So this will be 0 here. Now, this will be 0. Now, when that one is 0 and this is also 0, as you can see, is also 0, as you can see, the C is also 0. Now, if 0 and 0 for OR gate, it has to be 0. So that's the reason we have these two zeros here. Now we have the last one, so let's try to answer the last one. When A is equal to 1 means when this input is 1 and input B that is also 1, what will be the output? Because this is NAND gate. If it was AND gate, output has to be 1, but this is NAND gate, so it means output has to be 0. So that's reason we wrote our answer here, that is 0. Now next one, the C. When C is 1, mean this C is 1 and this is 0. What is our output? This is OR gate. It simply means if any input is 1, output should be 1. So that's the reason we have 1 here. So this is how we can answer. This is a quite straightforward way to answer this type of question. The best way, just write down what is given and just look at different gates and simply we can answer. I hope you have some better understanding to handle this type of questions now. So let's move on to next one, part D now. For part D, first of all, we need to understand simple electron model, and we need to distinguish electrical conductors from electrical insulators. So good conductor means they conduct electricity easily. So for example, when we talk about conductors, it means they conduct electricity easily. Conductor, simply we say material that can conduct electricity easily. So I will simply say conductor when I'm talking, it means conduct electricity easily. So this is first piece of information we need to understand. So we can simply say conduct electricity easily. The next one is insulators. That is just opposite. We will simply say insulators means cannot conduct. So simply we will say cannot conduct electricity easily. Cannot. Electricity is. So this is first thing what we need to understand about this. Okay, now using simple electron model we have to explain. So how we can explain this one? So one thing maybe most of you are quite clear, we call metals are very good conductors. So it means they have free electrons. So this is one piece of information. Metals are good thermal conductor and they are also good at conducting electricity. So they have free electrons. So now let's try to answer this one, how we can write a proper answer for part D. So this is how we can answer this question. So simply we need to say conductors have free electrons. Conductors have free electrons, so that's an electron can move freely, so they conduct electricity easily. And on the other hand, in insulators, electrons cannot move freely. Electrons are fixed. That's reason insulators are not very good electrical conductor. So this is how we can explain using simple electron model. So that's all for today's video, and I hope that you have better understanding about logic gates now, and also different symbols of logic gates, how to identify them, and how to write tables for different logic gates. That's all for today's video. Stay tuned until next video.